Hi class. In this video, I'm going to be going over constructivist theories in mathematics, which is one of the most important things you'll need to learn and take away and apply from this course. So let's go ahead and jump in. Okay, so what is constructivism? So constructivism is based on the idea that people actively construct or make their own knowledge, and that reality is determined by your experiences as a learner. And so what that really means is that we are not told knowledge, but we actually have to construct it ourselves. This is really important in mathematics because often we grew up in a learning environment where the teacher told us how to solve and do mathematics, and we just kind of mimic what they said or how we were told to do it. The idea of constructivism really goes into this idea that we actually need our students to have experiences, and through those experiences, they develop understanding of mathematics. Let's take a young child, for example, before they go to school. Often, parents might, give a child a handful of, let's say, M&Ms, and they'll be like, "How many do you have?" And then they'll count with them, and the kid might count or miscount depending on, where they are in their learning process of counting. And through that counting of the objects, they learn how to count. Now, let's say the child has seven M&Ms in their hand, and they might accidentally count one of those M&Ms twice and say they're eight. Now, as a parent, you might correct your child and or put recount with the child to show them that there's seven. Now, through that experience, they're learning this idea of one-to-one correspondence that I actually can't count one of the M&Ms twice. Now, you can tell a child that, but until they've experienced it and really understand that I have to count each one once and only once to know how many there are, they're not going to really understand when you tell them, "Oh, you can't count that twice." So then we give them maybe a strategy. Like, let's put them in a line. In my hand, they're hard to count. You might accidentally count twice. So if they're in a line, maybe we can make sure we don't count some of them twice. And so through those experiences, a child learns that when they're counting, they can only count an object once. If I just told them, you can only count your M&Ms once, they really don't understand what I'm saying. But through that experience, they're constructing knowledge. And so, what constructivism really emphasizes is students need experience to construct knowledge. So, let's go ahead and take a look at that second bullet point, which learners use their previous knowledge as a foundation to build on new things that they learned. So, building off that idea of a child counting some M&Ms, now the last time we counted, we accidentally counted twice one of the M&Ms and we ended up with the incorrect quantity. So that was an experience, a prior knowledge that they had, and now we're going to build on that foundation. And so maybe next time you're counting, you hand them the M&Ms and they start counting them, and you ask them a question like, "Hey, remember last time we accidentally counted them wrong? Is there a way that we can make sure we only count each M&M once?" And then they can remember, "Oh, we put them in a line." And so then they use that previous knowledge to now apply it to the new situation. Maybe now they're counting the peas they have or the corn they have on their plate or something like that, or how many hair bands they have in a bag or something along those lines. And now they can start applying that. I have to make sure that I count objects only once. And maybe they count one and move it to the side and pull it out of the bag and move it to the side. And they're counting one at a time. Now, our previous knowledge is our foundation for new learning. So we got to make sure students have strong experiences in those foundational skills if we want to keep building upon them. Now, knowledge is constructed, and that means knowledge is not given. As a teacher, I can't say, "Boys and girls, here are fractions. look at this. We have a number on the top. We call that the numerator, a number on the bottom. We call that denominator. Now you know what fractions are. But they actually have to experience and construct knowledge through those experiences. They have to be an active part, part of the process. They cannot be just shown things like, okay, now let's look at a fraction. See this circle? It's divided into two parts, and one part is shaded in, and I call that half. That would be a passive process where the student is watching the teacher explain something, but they're not an active part of that. So how I would make them an active part of that is maybe everybody gets a piece of paper. We're going to take our one piece of paper. How many pieces of paper do we have, boys and girls? Everybody has one piece of paper. Now, let me grab a piece of paper to show you. I got a sticky note here. Sticky note. So if I said, how many pieces of paper we have? One. Now, a fraction is when we take one thing and we divide it up into equal parts. And everybody take their sticky note and fold it down the middle. Okay, now we have one sticky note. And how many parts can you count on your sticky note? And the students would be able to physically, actively be a part of this and say, well, I count two parts. And then we can say, yes, the way we represent those two parts is called a denominator. And that's the number on a fraction that goes under the bar. Now, if I was going to color in one of those parts, maybe I would say, students, all right, let's grab your highlighter. And I want you to just color one of those parts. Now look at those parts. Let me see. It's colored in, it's shaded in over here. Now, how many parts have your shading or your coloring? Well, one does and one does not. So there are one part that's colored in, and then there are two parts in all. When we're looking at fractions, we're counting how many, may be shaded in, or how many were eaten, or how many of the pieces we're talking about. Well, right now we're talking about shading. So one part is shaded, one part is not. So that's how we write our fraction. So students being an active part of this process, not just the teacher showing them. They need to manipulate it. They need to feel it. I love to teach fractions with real life food because that's where students usually see fractions. So that's where learning gets to be contextual. We put it in a context that students understand. Students understand pizza, chocolate, all of those things. Those are things that are part of their life. So that's the personal connection. So if I say, hey, today we're going to get some pizza for the class, and each table is going to get one pizza, and we're going to look at how many pieces we eat at the table and how many in all. Then students have a social context that they're working in. They're working with their peers. They're saying maybe tables have 4 students at them, and the pizza's cut into 8 slices. And so you're looking at the pizza and you're going, okay, well, if everybody gets one piece of pizza, how many pieces were eaten? Well, 4 pieces were eaten, and there's still 4 left, but the denominator is not how many is left. The denominator is how many was in the whole pizza. So think about how many pieces we started with. Now let's build a fraction based on that. So there's a social aspect to it, there's a contextual aspect to it, and there's that personal learning connection where they have an experience that they can anchor this into. Now, when we're working with constructivism, students are really a part of that process. The teacher is not that sage on the stage going, here is my knowledge and I give it to you. Students are actually constructing that knowledge, and then we just help them make those connections. Like, here's how we represent that with mathematics. We represent that using numbers, a fraction bar. The number on the top represents, the number that either is eaten or taken away, the number that we're talking about, and the number on the bottom is how many is in the whole. And students start to actively make a connection between that personal and contextual understanding they have, that foundation of knowledge that they came with, And now you're adding on and building on to that foundation by showing them, well, this is how we represent it in mathematics, and we call these fractions. And fractions are different than other numbers because there's a relationship between the two numbers. There's a relationship between the top number, the numerator, and the bottom number, the denominator. And so constructivism really is about students being active part, building off their personal knowledge, building off of context that they understand. So let's go ahead and take a look at an example and a non-example. All right, so I chose a third grade standard because that's kind of middle of the road for elementary. 308A1. And this standard is the standard where students are really introduced to the idea and the concept of multiplication. So the standard is interpret products of whole numbers. So interpret 5 times 7 as the total number of objects in a group, in 5 groups of 7 each. So you have to describe a context in which the objects can be expressed as 5 times 7. So let's give an example. I have 5 different bags. Inside each bag, I have 7 apples. And so how many apples do I have in total? And so that's kind of the essence of this standard, really, when multiplication is introduced to students in 3rd grade. So my non-example of constructivist way to introduce this is going to be in Engage New York curriculum, and their grade 3 module 1 lesson 1 really jumps into this before students have an experience to anchor into. So let's go ahead and take a look at that. Okay, so here is the math curriculum from Engage New York. And a lot of school districts do use this because it is a free curriculum, but I wanted to demonstrate really the difference between constructivism and having a few strategies embedded in, and constructivism at its truest form, which is a different type of lesson. So this is lesson 1 of 3rd grade, and they start with counters. So using counters, that's super constructivist. We have a little bit of a constructivist strategy in here. We have kids using counters, which is very hands-on. So it says problem 1, skip count to find the total number of objects. Select 10 students to come at the front and say how many arms each of you have. 2 arms. So we're really starting with a quick constructivist activity where they're counting by, skip counting by the students in the front. Since each of the students represent a group of 2 arms, let's skip count our volunteers by 2s and have them come together. So they are starting constructivists. They're starting here with a little activity where they have students' experiences. They're anchoring it into personal connections and things that they know and knowledge that they come with. So after they go through that, they quickly jump into this idea of skip counting by 2s and getting to 20, and they jump into a very abstract teacher model of that. And so see, this is really guided by the teacher, and the teacher is the one kind of guiding there. And that's why I say this has got constructivist embedded in, but not quite a deep constructivist model. So then they go into just one quick example like that, and then they go into a second problem where they have 12 counters and they jump right to make equal groups. I want you to make equal groups of 2, and they jump right into the multiplication. So we definitely have a few slight constructivist strategies embedded into this Engage New York or Eureka Math, goes by both names, strategy, but they jump straight out of constructivism with teacher modeling before they really get a chance to really understand it and kind of grapple and critical think before the teacher reveals thinking. And that's why I say this is a non-example, because in constructivism, students really have to take the hold of the critical thinking and not the teacher. So let's go ahead and look at an example which is San Francisco Unified School District. They have a curriculum that is free for elementary. Their middle school is not free yet, but I believe they're working on that. But you can go and pull either of these curriculums for free and look at them. Now, their unit 3 is when multiplication is introduced. And the way the San Francisco puts their constructivist type, their curriculum is very constructivist. And they start each unit with an entry task. And this means that before that teacher gets up there and guides thinking, the students have a task at the beginning of the unit that really gets them going. Let me go up to show you that real quick. Really gets them going. So what do they already know about this topic? So this is how their units are designed. They'll have an entry task and then a lesson series that includes some tasks, an apprentice task, so you can get the sense of what they're learning. Then they have some more lessons, and then an expert task, which is how do they apply what they've learned to a new situation. And then a little more lessons, and then they have a milestone task. Did you learn what was expected from this unit? Okay, so let's take a look at the entry task, and I'll show you why this is more constructivist than Engage New York's quick. Hey, let's do a quick activity and look at how many arms and count them together. And now I'm going to show you repeated division. So with the San Francisco curriculum, they always start with this entry task. And so they are starting here with a task, and task-based learning, starting with a problem and having kids solve it, not collaboratively per se, not as a class, but on their own or in social groups, in cooperative groups. So you would start with this problem, which is called dog ears. And if you click on it, they'll show you what it looks like. Let's check quick. Marlena is walking 3 dogs. Each dog has 2 ears. How many ears do they have all together? And so you just give them that problem by launching it. And you ask any students if they have any dogs at home. How would you describe them? And then you maybe want to notice any math they mentioned, like they have 4 legs, 2 ears, 2 eyes, so on. So you read the dog ears with students, answer any questions they have, and then you just make materials available to them. Maybe counters or tiles or whatever it may be. You give them this paper and show how you would solve this problem. And you don't tell them how to solve it. You just say, off you go. And they're the ones thinking about it. They're the ones thinking, should I skip count? See how in the Engage New York one, the teacher led them to skip counting. The teacher said, here, I'm going to give you a strategy. Let's skip count. But in a more constructivist lesson, the teacher's not giving you ideas. They're making sure you understand the problem and what it's asking, and that's it. And they say, off you go. Now, you provide them a few minutes to work on their own, so they're having to think on their own. And then you can group them up for that social interaction. After some time, give them a poster paper and let them explain their thinking. And they get some ideas of how you can use group work protocols so that students are being on task and doing what's expected of them. And then after that, you walk around and you observe and you ask them questions and you see exactly how they're solving it. And the things you're observing are they creating equal groups? Are they drawing pictures to represent the dogs and the ears? Are they counting to find the total? How are they counting? Are they skip counting? Are they counting all? And can they translate this into a number sentence? And so after, you want to then bring up the students' work and talk about the different ways that they solved it. So you might have students who counted all. And so you might see a picture like this. This is some examples of ways they might have drawn it. So they went 1, 2, 3, 4, 5, 6 ears. You might have kids who have skip counted or doubled. So you might see, this dog has 2, this dog has 2, this has 2, total of 6, or 2 and 2 and 2 is 6, or 2 plus 2 plus 2 is 6. Or you might see multiplication, which if this is your first lesson, is unlikely, but some students come already with some background knowledge, whether they were taught by their parents or they're in advanced mathematics, or they've already done this unit in their other school and they switch schools. So you might have any of these strategies. Now, what you do in a constructivist classroom is you present student strategies, not teacher ideas. They're the ones who come to the table with these strategies. Now, sometimes you do have to give them a nudge and say, hey, this kid last year showed me this strategy. What do you think about it? If you don't get a strategy you really want to introduce. And that happens at times where you're like, oh, I want to teach them, this idea of 3 times 2 eventually. And if so, no one is ever doing that, you do introduce new strategies, but you always start with that student thinking and you represent that student thinking. And so this is where teaching happens in a constructivist lesson. See how the students already had a task. They solved it on their own. We presented their solution. We compare and contrast their solutions. So we look at how is counting all this picture different than the way, and I always give it names. So let's say Maria did the picture of the dogs. How is her strategy different than Justin's strategy of this dog and two and two? And how is it the same? Well, definitely represented 3 dogs. They represented 2 ears on 3 dogs, but Maria counted each dog ear where Justin showed 2 dog ears per person. So then it goes into how we can represent and discuss. So you choose 2 to 3 student works to discuss. And while you're walking around, you're choosing which student work samples you want to discuss. You're looking for those differences. You don't want 3 of the same thing. You want a kid who counted all. You wanted a kid who skip counted, and you have different ways. So you have opportunities to compare and contrast. Often I walk around and I say, hey, Maria, I really like yours. Just so you know, we're going to talk about it after when we come back together as a class. So she's ready to talk about what she did. She knows she's going to be called on. And so you'll go ahead and, show those models. You'll start using descriptive language, like look at these groups or each and things like that. If no students use the multiplication notation, you can tell them now, this is one way we can notate it. And you show them that's where your teaching comes in. And then the San Francisco way really just kind of goes through that. And then they might then go and have an extension afterwards and do another problem. So if you had 2 dogs, how many ears would they be? And so in their notebook, that would be them showing their learning or their check from understanding their formative assessment at the end. And maybe they would be writing a multiplication word problem on their own or matching an equation as an extension if they're ready for it. And then the next day, then you start the lessons and they give you different ways. So that is an example of our example and a non-example, which had a few constructivist strategies embedded in, but was not a constructivist lesson. So when we look at my example and my non-example had a few strategies embedded in, and my example was a true constructivist lesson. If you're looking for where to get that San Francisco curriculum, you can really just type in SFUSD math portals and you will get to all of their curriculum and it's free for you to look at and download. So let's just talk about a few constructivist strategies in math because this will apply to your assignment this week. So constructivist strategies often are hands-on. So you give students the opportunity to use manipulatives. Like the San Francisco task showed, you give them tiles. If they want to use them, they can use them. The examples they showed didn't have any students using tiles, and some students might prefer to draw a picture, but they should always have access to manipulatives. And so in a constructivist classroom, either students have their own manipulative kits or tables have their own manipulative kits, or they're in a location and students are told and know they can grab them at any time that they need them. Students should have access to our hands-on materials. It includes exploration before any thinking is stolen from students. So in the Engage New York example, the teacher did not allow students to critically think about that problem before telling them you can skip count. And that's really that big difference. We want students to engage in problem solving and critical thinking prior to teachers giving ideas to students. Let them figure it out for themselves. It's those experiences that help them understand mathematics. Often they include cooperative learning where students are working together. But you notice in the San Francisco example, they had to think on their own first before cooperative learning was introduced. Often we analyze misconceptions. So if students are having, a misconception about something, we might analyze it as a class and look at it and talk about it and see why that misconception is there. Maybe a student is like, let's say we're regrouping and doing subtraction where we have to regroup. Maybe a student is borrowing or regrouping and taking a 10 away to make 10 ones, but they don't actually take the 10 away. They just give the 10 ones to the ones place. And so there's a misconception we might analyze, and we could look at that together and talk about, well, why doesn't that work? And why do we have to go to the tens place and take one away? And we model it with our manipulatives and we talk about those misconceptions and why they're there. It often includes explaining how and why something works. So students just don't follow rote procedures. I learned to borrow in second grade or regroup in second grade because my teacher told me this is how I do it, not because I had a deep understanding of, well, if there are no ones, I can get ones by regrouping a 10 into ones and understanding that process. And so we have to be able to explain how or why something works before we ever get to an abstract model, like just a straight algorithm of subtraction with regrouping. Students have to show models, they have to show why we regroup, they have to understand that process before we move them to abstract like an algorithm. That's why many parents struggle with the new math is because they're like, well, we just learned to regroup. We don't need to do all these extra steps. It does take longer to build models and draw pictures. The parents are right. But what it doesn't do is help students understand how or why they're following these rote procedures. Math is not a recipe. Math needs to be something students construct to understand. Otherwise, they cannot really understand what's happening mathematically. They don't have good number sense. And when students don't have good number sense, mathematic achievement is low. Then we look at multiple solutions and strategies. Oh, that's spelled wrong. So when we're looking at multiple solutions and strategies, there's a creativity aspect in math. There are many ways to get to a different solution, and students start to understand that it's not my way is the right way, the teacher's way is the right way. We can think about math in a lot of different ways, as we saw in that multiplication example. We can think about it as 2 plus 2 plus 2. We can think about it as 2, 4, 6, 8. We can think about it as 1, 2, 3, 4, 5, 6. We can think about it in a lot of different ways, and there's not one right, wrong way to get an answer. It just has to make sense mathematically. Students often that struggle with mathematics have this idea that they don't understand it. They don't understand the one way that's presented to them, so they're dumb, or they don't know math, they're bad at math, but actually just they don't understand the one way that was presented to them. There are other ways that they can understand mathematics and approach it. So it includes problem solving, like we saw with that problem. The kids were solving the problem, not the teacher. The kids need to solve the problems. They had to do the thinking. The teacher is highlighting the thinking. And so that comes to it is student centered, not teacher centered. If the teacher is up there presenting all the thinking and all of the ideas, that is a teacher centered classroom. You want to have a student centered classroom where you're pulling strategies from the students, not yourself. The students can learn more from their peers often than they do from the teacher. They see you as a college graduate, as somebody who's super smart, and so they're going to listen to and mimic what you do. But when they see their peers taking risks and trying new things, they actually end up learning a lot from their peers, especially when we compare and contrast solution strategies. All right, so that's my brief overview of constructivism in mathematics. I hope this really helps you as you're trying to understand what constructivism looks like and as you're analyzing and making tweaks to the lessons that you do in this week's assignment. If you have any questions about what constructivism is or how it looks in the classroom, don't hesitate to add a comment onto this forum post or reach out in text or email or whatever. I'm here to support you guys in your learning throughout this course.